Well, let's try this one here. So we got two identical curling stones of mass 19.5 kilograms colliding. That's pretty heavy. First stone hits the stationary second stone with a velocity of 5 meters per second north. If the velocity of the first stone is 3.2 meters per second north 30 west after collision, find the velocity of the second stone after collision, omit friction. Okay, so let's draw a picture. So we've got, why am I looking for markers there? That's silly. I doubt that, but let's talk about Nate. Let's talk about this question. Okay, so we've got one, I'll call it rock 1, and rock 2. Okay, so rock 2 is slightly offset like this, right? So it hits like this. Well, it doesn't say that, but it says that the velocity of the first stone is 3.2 north 30 west after collision. So if the first one goes north 30 west, if the first one goes this way, right, after, then the second one's going to have to go that way, right? So, yeah, well, you'd have to reason that out, right? I would probably, in a situation like this, I would probably give you some kind of picture or something to get you going here. Good tip. Okay, so again, let's start with PI is equal to PF, right? The initial momentum must equal the final momentum. What makes up the initial momentum? We'll call it rock 1 and rock 2. What is the rock 2 is at rest, so the initial momentum is the momentum of rock 1 initial, right? P1I. That is what the initial momentum is. And afterwards, what is the total momentum? That's going to be P1. Do you want me to use primes or Fs? Prime. So P1 prime plus P2 prime. Then I guess if we're going to use primes, then this is just P1, right? Prime just means after the collision. It's another way of saying final, Nate. Okay? So what is, now we need to find, we are looking for, find the velocity of the second stone after the collision. So the second stone, we're looking for momentum of 2, right? Okay, so I'm going to take that P1 prime to the other side, and I'm going to say P1 minus P1 prime is equal to P2 prime. Because we are solving for find the velocity of the second stone, so P2, after the collision, which is P2 prime, right? If I know the velocity, if I know the momentum of the second stone, I can get the velocity of the second stone. Yes. Again, Nate, you're not listening. P equals mv, right? If I know the momentum of rock 2 and I know the mass of rock 2, I can find the velocity of rock 2, right? Okay, so here is my vector subtraction. So I've got to take P1. It's really, now it's just become a vector subtraction question. Has it not? Okay, so let's find the momentum, x and y, the components of P1. So P1x, P1y. Well, P1, the rock here, rock number 1, is going straight north. So it has no x component at all. And the y component is the entire momentum. It's 19.5 kilograms, and it's moving at an initial speed of 5. 19.5 times 5. Because that's the mass and that's the velocity. Well, momentum of rock 1y is the momentum, 19.5 times 5. It's the y component of that, but it's all y. It's just north. You'd have to go sine cos, right? The x is nothing. There's no sideways momentum. It's all upwards, right? So that gives me 97.5. Right? Good enough, Josh, yeah? Good questions are good. Okay. Now, P, the thing we're going to subtract is P1 prime. Right? So P1 prime. P1 prime y and P1 y prime. Oh, I put them both y. And I switched to green for some silly reason, too. Yep, this is the initial momentum, P1x and P1y, and now the finals, P1 prime x and P1 y prime, or P1 prime y, I don't know. Okay, back to our initial here. We've got the velocity of the first stone is 3.2 north 30 west after collision. So that's the numbers that we're concerned about, but it's also times 19.5, right? North 30 west. Maybe I should actually draw a picture. North 30 west. North 30 west. It's 19.5, and the velocity was 3.2, right? We got that from the initial statement. So P1x, that's going to be this top one here, that's going to be opposite. So P1x is going to be, this is T1, rock 1, 19.5 times the velocity, 3.2. We want the x component. It's here. It's opposite. It's sine 30. And the other one's going to be the adjacent. North 30 west, 19.5 times 3.2 times the cosine of 30. Please tell me I have these. Say that again? Yep. If you want, like we could have, maybe you might feel better if I took 19.5. Okay. I mean, if you want, I can do this. I can take 19.5 times 3.2, and that gives us 62.4. I just want this point. Give me that one. 62.4. If you want, you can go 19.5 times 3.2 is 62.4 kilogram meters per second. That's the momentum. And then find the component of that, right? Kurt's a little bit confused by how this is written here. Yeah. It's all multiply. Kilogram meters per second are units for momentum. Newton seconds, impulse. 62, so this is going to give you, this is going to give me 31.2, I think, right? Okay, excellent. 31.2. Now you should note, Nate, stay with me here. You should note that the x is to the left, and so that is actually negative. As I just finished saying, it was to the left. See, that's that whole part about the listening, Nate. Yeah. Okay, I know. 62.4, this is going to be cosine 30. Up, so positive, right? Okay. Now, we are doing P1 minus P1 prime minus vector subtraction, right? Nate has a question.
So the main gist of this story
Don't eat yellow snow. Yeah.
Keep the rocks separate.
Oh, yeah.
That's my problem. I can't mix them up. Like, what's going on?
Okay, so I'm going to subtract, right? So I've got, I'm getting value. How do we know to subtract? Because I set it up right here.
So we just follow our thing.
So P2 is P1 minus P1 prime. So I'm going to subtract. P2x is going to be 0 subtract minus 31.2 or 31.2. P2y is going to be 97.5 subtract 54. Going to check my work here that I did it right. $43.5. Positive, positive. Yes, Mr. Burnett. We're almost done. Now I got to take those components and do what? Put them back together, right? So I got 31.2 is positive.
So we're looking for the final velocity.
We need the final momentum of rock 2 so we can find the final velocity of rock 2.
Yeah.
So 31.2 to the right and 43.5 to the up. And that is momentum of rock 2, and that is final momentum, right? P2 prime. Right? Do we have what? We're going to. So P2 prime squared. Yeah, it's weird looking. 31.2 squared plus 43.5 squared. P2 prime is going to be... Okay, Nate. You couldn't do that on your own? Oh.
There you go.
I guess technically it would be this.
Yeah.
P2 prime is then, I get 53.5. That's what you got? And that's going to be kilogram meters per second. This question isn't too bad. Like, it's not, I mean, relative, right? Like, it's not bad. 53.5. Now we're going to have to find the angle. I started on the test yesterday and then I quit. I probably shouldn't have because you get. We're going to get, yeah, just a second. Chikai. Oh, Nate. Right back to the start. P2 is what we're solving for. P2. Yeah. What did you think it was called P2 for? How does this eraser thing work again? If I do this, yeah, and tap it in the middle. Oh, burn, baby, burn. Maybe Cole's listening at home later tonight. That would be good, actually. Yeah, I'm recording. Angle, 35.6. No, the opposite of that, Bennett. What is it? Yeah. And that's going to be east, 54.3 north, right? I just listened to you. 54.4. Okay, but what is the actual velocity? P equals mv, so I take this number here, 53.5. Mm-hmm. I'm doing better today than the other day. Thank you. I felt bad. Because it was not my best effort the other day.
Wow.
And you deserve the best effort. You deserve my best every day, Nate.
It's better.
How many marks would you think?
8, at least.
Let's see.
No.
One there for that, one for the angle, one for that, probably one for doing the subtraction, one for that, and I guess, is there 1 mark for doing this?
Yeah, equals
I mean,
you should know that. That's fine.
do you have to do that to solve the question? Not really, but to get your thinking, yeah, like if you don't do that, you can't really it's sort of your blueprint for the whole thing, right? PI equals PF. It's how everything starts, right? And then it's about fitting in what is the initial momentum, what makes up the initial momentum, what makes up the final momentum. So I go, no, Nate. No. What does P1, what is the PI made up of? What's the initial momentum made up of? Rock 1's momentum, right? That's not a equation, it's just a statement. What makes up the final momentum? The momentum of rock 1 prime plus the momentum of rock 2 prime. If rock 2 was moving, then the whole thing we'd have a P2 in there, wouldn't there, right? Like you just have to think about the situation. This statement here is all about that particular situation, right? This one is always going to be there. This one is what makes up the situation, and this one is, I guess, how do I get to where I want to go? Right? This tells me it's vector subtraction. Yes, Nate. Another question. If I only had a nickel for every question. How about you try it first? Well, now that you've gone through this, maybe you'll get it. You give it a whirl and see. Okay.